Hi girls, this video is going over sign diagrams. So sign diagrams are useful to check when a function is above the x-axis or positive and below the x-axis or negative. Now notice there I said a function. So when a function is positive or negative, keep in mind the function equals the y value. So what we're really doing is checking whether the y value is positive or negative. So to draw a sign diagram, draw a horizontal line. This represents the x-axis. Place the x-intercepts on the line. Draw dashed vertical lines to indicate any asymptotes, and put plus and minus signs on either side of these x-intercepts. And can I add there, and asymptotes. Okay, so let's have a go. Example 1, draw a sign diagram for the following graphs. Okay, so I like to draw a red line for the x-axis. So it's like the x-axis there. Now we can see there are x-intercepts at 2 and 0. So I put in 2 and 0. There are no asymptotes, so I don't need to worry about that. And now on each side of these x-intercepts, I check what the sign is. So is it positive or negative? So we can see in this area here, when we're bigger than 2 or when x is bigger than 2, we're in the positive region. So above the x-axis, so we put a plus here. Now down here, we're below the x-axis. So in other words, the y would be negative. So we put a minus there. And then over here, we're again above the x-axis, so we put a plus there. And that's it. That's all you have to do for a sign diagram. Now for the B, again, I start with a horizontal line. And then, what x-intercept do I have? I have one at -1. I also have this y-intercept, but that doesn't matter. All I care about are the x-intercepts here. Now, on either side of -1, where is the function? On both sides, actually, the function is below the x-axis, because this here is the x-axis. So I'd put a minus there and a minus there. And finally, for the last one, now I'm going to draw my sign diagram over here. So what have we got? In this case, we've actually got no x-intercepts. But we do have, hopefully you realize, for y equals 1 on x, you do have a vertical asymptote at 0. So what I should do on my sign diagram is put a 0 there, and then I can do some dashed lines for an asymptote, just so I know that I'm not talking about an x-intercept, I'm talking about an asymptote. So now, on either side of this asymptote, where are we? Well, over here, we're above the x-axis, so I'll put a positive. Over here, we're below the x-axis, so I'll put a negative. And that's it. So now, note, when a factor has an odd power, the sign changes on either side of the x-intercept. When a factor has an even power, the sign does not change. So what am I talking about? Back here, look at the original equation. You've got y equals x and x minus 2. Sorry, x and x minus 2 are the factors. Both of those are not being squared, or neither of those being squared or to the power of 4 or anything. So they both have odd powers of 1. So it's like x to the 1 and x minus 2 to the 1. So because they both have odd powers, on either side of the corresponding x-intercepts, the sign changes. So on either side of 0, we go from positive to negative, and on either side of 2, we go from negative to positive. Or in other words, the function itself crosses the x-intercept and then crosses it again. But on this side over here, with x plus 1 squared, notice that the function kind of bounces at -1. It stays on the same side of the x-intercept. So on either side of the x-intercept of -1, the sign didn't change. It was negative on both sides. Let me just give you a few more examples of that. For instance, if I have y equals x plus 1 times x minus 3 squared. Okay, so notice this one has an odd power or an invisible power of 1, so that's odd. This one here has an even power. So according to the previous sentence, we expect it to be on the same side of the x-axis, and here we expect it to swap. So now you could draw this using Desmos or your GDC, but you'll see what will happen is this. So hopefully you know that according to each of these factors, the first one is x equals -1, the second one is x equals 3. So that means the x-intercepts are at -1 and 3. Now, what will happen is, now, for me to draw this without a calculator, what I can do is sub in an easy point like 0. So when x is 0, I get 0 plus 1 is 1, and then 0 minus 3 is -3, but -3 squared is 9, so 9 times 1 is 9. So I'm actually up here somewhere. Now, if I substitute something like x is 4, I'll get 4 plus 1, which is 5, and 4 minus 3, which is 1, so 5 times 1 is 5. So I expect to be somewhere here-ish. So what this function actually looks like, and you can check on your calculator if you're not sure, it looks something like this. Okay. That's what this function looks like, something like that. So what I'm trying to explain to you is, because this one here has an even power, we bounced on the x-intercept. We stayed on the same side of the x-axis on either side. And here, because x plus 1 has an odd power, we went through the x-axis. We passed through it. We didn't bounce back, we passed through it. So this function here would have a sign diagram of, okay, the x-intercepts are -1 and 3. So what's it doing? On this side of -1, we're below the x-axis, so we're negative. Between -1 and 3, we're positive. And then on the other side of the 3, we're positive again. So hopefully that makes sense. Okay. Next question. Draw sign diagrams for the following equations. Let's try it without without actually drawing the graph. So for this one, what are my x-intercepts? Hopefully you realize that gives you x equals 2, and this one gives you x equals -4. So we have -4 and 2 on our sign diagram. Now let's check what happens between them. So, for instance, a value between -4 and 2 is like 0. So I'm going to put that in. What's 0 minus 2? That's -2. 0 plus 4 is 4. So -2 times 4 is -8. So I'm negative in here. Now over at, say, 3. 3 is on this side. 3 minus 2 is 1. 3 plus 4 is 7. 7 times 1 is 7. So it's positive. And now at, say, -5. -5 minus 2 is -7. -5 plus 4 is -1. So -7 times -1 is +7. So we get positive again. So that's my sign diagram without drawing the function. And hopefully you realize that both of these factors have invisible odd powers of 1. Therefore, it makes sense that the sign changed on either side. So here we went from positive to negative, then we went from negative to positive. So it goes with what we were saying before. Now for B, here's our sign diagram. Whoops. Okay, so once again, we get the x-intercepts of -3 and +8. So let's put them in. -3 and +8. Now, take a moment, have a think. What do you expect to happen? Where do you expect us to change sign? And where do you expect us to stay the same sign. In other words, okay, since this factor here has an odd power of invisible 1, because it's an odd power, we expect it to change signs of around the corresponding x-intercept of -3. So in other words, we're expecting it to change signs about -3. At the other one, this has an even power of 2. We expect it to be, therefore, the same sign about 8. Let's see if we're correct. Okay. So we're going to sub in some points. What's a number between -3 and 8? Oh, 0. So let's put that in. 0 plus 3 is 3. 0 minus 8 is -8. But -8 squared is 64. 64 times 3 is 192, I believe. But then you have to negate it, so that becomes a negative. So you can do that all in your calculator if you like. Now I'm going to pick another number over here, like 10, on the other side of 8, I should say. 10 plus 3 is 13. 10 minus 8 is 2. 2 squared is 4. So 4 times 13 is 52. And then I have to negate it again because of this negative out the front, so don't forget that. And now let's pick a number on this side. So -4. -4 minus 8 is -12. Squared is 144. -4 plus 3 is -1 in here. So, and then you've got the negative out here, so there's another negative. So that cancels out these two negatives and we get 144. And that's positive. So let's see if our predictions were correct. Yes, we did change signs on either side of -3. And yes, we stayed the same sign on either side of 8. Okay. Now, guys, I just want to stress on what would this kind of thing look like then? So if we were to graph this function, so we got -3, +8, it looks something like, so we start at positive, so we're up here, then we go negative, so we go down, then we're going to bounce back at 8 and go down again. Oops, well, that was a bit of a wonky one at the end, but that's what this means. So -3 and -8 are x-intercepts, so we have to touch the x-axis at those points. And then the signs tell us, the positives and negatives, tell us whereabouts we are. So if you were to graph it on your calculator or Desmos, it would look similar to this, but not exactly because my drawing's kind of crap. Anyway, part C. I might rewrite it down the bottom here because I'm running. Actually, no, I can go over here. Okay. Part C. Y equals x on x minus 2. Now, let's take a moment. What are the x-intercepts? In other words, when does y equal 0? So that's when, if y is 0, then this whole fraction, I should say, equals 0. Now, hopefully you remember from a previous lesson that a fraction only equals 0 when the numerator equals 0. So therefore, that's when x equals 0. So x equals 0 is one of the x-intercepts. Now, I don't care about y-intercepts, so I don't need to worry about anything else there. Now, hopefully you also realize that there is a vertical asymptote when, now with fractions, when is it undefined? That's when the denominator equals 0. So in other words, when x minus 2 equals 0, also when x equals 2. So that is the vertical asymptote. So I've got my two, say, critical values, we sometimes call them. They're two important values that I've got to consider on my sign diagram. So it's 0 and 2. They're the important things. And if you remember, I say put a little dashed line so you remember that 2 actually is not an x-intercept, it's a asymptote. Okay, so now we're going to check what sign the function is on either side of all the 0 and 2. So let's choose 1 for in between 0 and 2. So what do we get? 1 over 1 minus 2, which is 1 over negative 1, so we get a negative. Okay, so now let's sub in something like 3 on this side. So 3 over 3 minus 2 is 3 over 1, or just 3, which is a positive. And now let's choose something like negative 1 on the other side of 0. Negative 1 over negative 1 minus 2, which becomes negative 1 over negative 3, which is 1 over 3, so it's positive. And there you go, that's our sign diagram. Okay, so I hope that helped with this topic. And all of that corresponds to exercise 2F. So please do some questions from there to make sure that you understand the concepts here. Thank you.